Hello everyone. In week 1, we will take a quick recall and revisit some of the concepts that you might have already studied in the course AI algorithms in your first semester. So basically in this video, we will look into an overview of AI and then take a closer look into what makes machine learning and deep learning different. So let's get started. First, definitely the question, what is artificial intelligence? So artificial intelligence is a way of artificially making a computer intelligent. It is a branch of computer science in which you programmatically code the machine to become intelligent. And according to the father of artificial intelligence, John McCarthy, it is the science and engineering of making intelligent machines, especially intelligent computer programs. The intuition and the motivation behind AI comes from the human brain. The one primary reason behind why we need AI is to automate tasks that people feel are redundant. Also, if you make a computer learn some data or records, based on these records, it can easily predict the future outcome, since it would have understood some patterns and structures from the past data or records. So this is a quick definition and introduction to what is artificial intelligence. Moving on, what is machine learning? So in the most basic sense, machine learning is a way to implement artificial intelligence. According to Arthur Samuel, machine learning is the study of how to make computer do things which at the moment we humans do better. So similar to artificial intelligence, machine learning is also a branch of computer science in which you diverse or study the design of algorithms that has the capacity to learn. And of course, there are various machine learning algorithms, starting with linear regression, logistic regression, k-nearest neighbor, naive Bayes decision trees, random forest, support vector machine, k-means clustering, Gaussian model, and hidden Markov model, and many more. So for machine learning, we use one of these algorithms which provides the computer the ability to automatically learn and understand without being explicitly programmed or without being programmed time and again. Now, the question is, how will the computer learn automatically? So, the answer is data. So you feed in the data having different attributes, or what we call as features, into the algorithms that we have just seen. And these algorithms have to understand and give us a decision boundary based on this data that you have provided. Once this algorithm has learned and interpreted the data, or in a simpler sense, once you have trained your algorithm on your data set, you can now put your algorithm into the testing phase. And in this testing phase, you can input test data points, or what we call as records, and expect it to give you some results. And based on these results, or based on the type of algorithm that we have used, we can choose the corresponding metrics to determine how well our test data or the test data result matches the actual output. For example, if you have used a regression algorithm, probably you can have a root mean square in order to judge how well your test data performs. Similarly, if you are using a classification algorithm, you could probably use accuracy metrics. We have already discussed that machine learning is to come up with the design of algorithms that has the capacity to learn. And these were some of the algorithms. There are more to it. These are some of the basic machine learning algorithms. Now, you should have already studied that the machine learning algorithms can be classified broadly into three categories: the supervised learning algorithms, unsupervised algorithms, and the reinforcement learning. Let us quickly discuss what these three types of algorithm means. The first type is supervised learning. So as the name suggests, it is supervised, which means it works under supervision. So it is a learning technique wherein which the whole learning program is governed or supervised. And these learning algorithms' main goal is to predict the outcome given a set of training samples along with the training labels. Or in short, for a supervised learning algorithm, we have labeled data set. Labeled data set means you will have the features or the attributes of each of the records in the data set along with its actual Y value. So you will have X columns as well as a Y column. So since you tell this algorithm, the supervised learning algorithm, at training time what it should predict, that is the Y value, it is called as supervised learning. And the supervised learning algorithms are further classified into regression algorithms and classification algorithms. The regression algorithms example is linear regression, and in a regression algorithm the output Y value will be a continuous valued output, Whereas in classification algorithms like logistic regression, you have a discrete valued output. For example, if you build an model to predict the housing price. Now, housing price can range from, say, 0 to any particular value, right? Or it can have a continuous valued output. Whereas if you build an model to predict if a person has benign or malignant tumor, then basically it is a classification problem because you have only a discrete valued output that is definitely between a very small range. In our case, it is benign and malignant, that means 0 and 1. It is a binary output. The second class of machine learning algorithms is the unsupervised learning algorithms. And the example is k-means clustering. So, unlike your supervised learning, in an unsupervised learning, you have no training labels for your training samples. Or in short, you have an unlabeled data set. You will have only X columns in your data set and no target Y columns. These algorithms are formulated in such a way that they can find suitable structures and patterns in the data. Once these consistent patterns become apparent, the similar data points can be clustered together and the different data point will be in different clusters. And this unsupervised learning algorithms are mainly used to project high-dimensional data into low-dimensional data for visualization purpose and also for the purpose of analysis. Apart from supervised and unsupervised learning algorithms, there are also a third category called as reinforcement learning. So this is a type of machine learning that has an agent that learns how to behave in an environment by taking actions and quantifying the results. If the agent makes a correct response, it gets a reward point which boosts up the agent's confidence to take more such actions. And one example of this reinforcement learning is the Markov decision process. Deep learning. So this is a common figure that we all might have seen, which says deep learning is a subcategory of machine learning. Deep learning is inspired by artificial neural network, which is commonly called as ANN. And this artificial neural network is inspired by human biological neural network. So a deep learning is one way of executing your machine learning. If we consider any artificial neural network, it consists of an input layer, a hidden layer, and an output layer. The hidden layers are commonly known as weights or parameters, which are learned while the neural network is being trained. And the output layer, which is the final layer, gives you the prediction for the corresponding input which you feed into your neural network. So a neural network is an approximation function in which the network tries to learn the parameters or the weight in these hidden layers, which when multiplied with the input layer gives you the predicted output close enough to your desired output. And this first figure is an example of a simple neural network or a simple artificial neural network. A deep learning is nothing but stacking multiple such hidden layers between the input and the output layer. So a deep neural network will be a longer version or a dense version of a simple neural network. Now let us check what are the differences between a deep learning and a machine learning. The first and the most important difference is feature extraction. This figure completely summarizes how a deep learning is different from machine learning in terms of feature extraction. So as we can see, a deep learning is considered to be a very suitable method for extracting meaningful features from the raw data. It does not depend on handcrafted features. Or most importantly, deep learning performs a hierarchical feature extraction. On the other hand, as we can see, the traditional machine learning relies on handcrafted features. So there should be a very intense human interference required in order to get these in order to extract these features from the raw data before it could be fed into a machine learning model. As I have mentioned, for a deep learning, there is no need of a manual or a handcrafted feature extraction because that itself is performed by our hidden layers of our deep neural network. And these feature extraction takes place as a hierarchical feature extraction, which means it learns the features layer-wise, or it means that the initial hidden layer learns the lower level features, and as it moves up in the hierarchy, it starts to learn a more abstract representation of the data. For example, in this example shown in the slide, where it is definitely an image recognition system or an image classification, or it could be an object detection system, as you can see, the first hidden layer extract the most lower level features. Probably we could say it extract the edges. And as we go higher in the architecture to my next hidden layer, it starts to extract features like more abstract features like eyes, nose, or probably the texture, right? And finally, the third hidden layer almost learns the most complex or the abstract representation of this data. So a deep learning network has a layer-wise learning of the features. And again, here the features can mean either pixel values, shape, texture, color, orientation, etc. So we know that the accuracy or the efficiency of the model that you develop depends on the features that is being extracted. So in the case of a traditional machine learning algorithms, the performance of this model depends upon how well a human engineer extract and identify these features. Whereas in the case of deep learning, these features are learned by the combination of the layers at different levels and finally combine them to form a bigger picture as an abstract representation. Also, if we have a structured data, feature extraction by a human can approximately be correct, or to a great extent be correct. But this manual feature extraction becomes difficult, or the hand-drafted or handcrafted feature extraction becomes very difficult when you have a unstructured data like an image. That is why when you have your data set as an image, rather than going with any traditional machine learning approach, people do prefer the deep learning approach, because the feature extraction and the corresponding, say, classification model can be built by the same neural network. So the first major difference between the machine learning and deep learning approach is feature extraction. The second difference between the two is data dependency. So we can see this graph between amount of data and performance, and this is the curve for a traditional machine learning algorithm, wherein which the performance of the model almost gets saturated after a particular amount of data. So at some point, even though we increase the amount of data, the performance of the model remains the same. And the machine learning algorithm often works well even if the data set is small. But a deep learning is a data hungry model, and the more data you have, the better is the performance of your deep learning model. So as we can see, the performance of a deep learning model increases with the amount of data. And this again changes depending upon how small or large your model is. So if you have a smaller neural network, which means you have only few hidden layers in your neural network or few neurons in each of these hidden layers, that means it is a smaller network. So as the size of the network increases and more dense your neural network is, the more data hungry your network becomes. So this is another important difference between a machine learning and deep learning algorithm. The third major difference between a deep learning and machine learning model is computational power. So as we have just seen that the deep learning network are very much data dependent, which means that it requires more computational power than what a CPU can offer. So most of the time, a deep learning neural network need a GPU or a graphical processing unit for us to train the model. And this computational power not only depends upon the amount of data, but also how deep or large your neural network is. So as you increase the amount of data and also as you increase the number of layers, you will need more computational power in order to train your model. And the last most important difference between the deep learning and machine learning model are, of course, the training time. So the training time of a deep neural network can range from anywhere between a few hours to months. Again, if you have vast number of data for training a neural network, again it usually takes more time. Moreover, if you increase the number of layers in your neural network, it means that the number of parameters or the weight increases, which in turn increases the amount of time to train your data set using a deep learning model. Not only training but very vast and very deep neural network can also take a lot of inference time, since the input test data will pass through a number of layers in your network, which means a lot of multiplication operation will take place, and that will again consume a considerable amount of time. But when we compare this with a traditional machine learning algorithm, often the training is very fast and it might range from very few minutes to maybe a couple of hours. So these are the four important differences between deep learning and machine learning algorithms: feature extraction, data dependency, computational power, and of course the training time.